Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Konrad.
Thank you for joining me on this live stream. Normally, the Reliability Matters podcast does not do live events. We normally pre-record, but this time we decided to throw caution to the wind. We'll decide later if that was a good idea, and we'll see how this works. Thank you for subscribing and watching or listening to the Reliability Matters podcast. I'm so pleased that you're part of our podcast family, and I'm also very pleased to report that we have, as of this morning, a little over 20,000, almost 21,000 downloads. So that is extremely exciting. I really appreciate the support our industry has given this program. Our first episode was on July 12th, 2018, and I literally recorded that in my closet because that was the only place I could get kind of the acoustically superior sound compared to the rest of my house, which was very echoey. I've since built a studio, and I'll give you some studio views later on in the broadcast. The first video version came out. We did audio only broadcasts for the first year and a half or so. And then in August of 2020, we started the Reliability Matters YouTube channel. And so for those who like to watch rather than listen, the YouTube channel is available. Normally we don't broadcast on LinkedIn. It's just YouTube. Today is a little bit different, of course. We've had in the last 100 episodes, I've interviewed 117 guests, all subject matter experts in their field. And they range from all sorts of subjects, from failure analysis to best practices in reflow, printing, solder materials, thermal management, and so much more. Our podcasts are currently available on Apple Podcasts, Google Podcasts, Spotify, Amazon Music, iHeartRadio, and at least 1,000 other channels. I'm not sure where you listen to it on, but it's available in a lot of different places. And we also have this show syndicated on Circuit Assembly Magazine's PCB Chat at pcbchat.com and at Ascendo Reliability at reliability.fm. And I'm very grateful to our two syndicators for syndicating this show. That would be Mike Butow, editor-in-chief of Circuits Assembly Magazine, and Fred Schenkelberg from Ascendo Reliability. So I'm very grateful to those folks for syndicating the show. Today's show is, again, quite unique. I don't have any live guests on the show. I'm the only person live for this episode, for this broadcast. But we're going to show clips from prior shows. I can't really say these are my favorite clips because they're all my favorite clips. Each episode is, it's kind of like children. You like all your children. You love all your children. And I like and love all the guests that I've had. But I pulled a few clips from prior episodes that stood out in my mind. We're also going to listen to, throughout this broadcast, messages from prior guests. I had several guests send me audio messages and giving me their impressions of the show and reliability in general, not just the show. So our first guest, my first guest, was way back in December of 2018, and it was my friend and colleague Bob Willis. It's an audio-only clip because we didn't do video back then on this show. But let me switch over to my friend and colleague Bob Willis, who was talking about process defects.
If we talk about sort of process defects, I still see so many process defects associated with surface finish on PCBs. That's still, very, very common. It always reminds me of the one of the videos I made back when I was making videos. I introduced a video on a guide to surface finishes, and it was my worst selling video. And although that particular problem has just gone on and on and on for years, it's really weird. The other thing that I tend to see, is that today a lot of designers don't specify the PCBs correctly. They quote IPC or, a standard or a reference, but they don't understand the standard. So they'll say, I want this to IPC XYZ, but they've never read the standard. Or if they specify something to a PCB manufacturer, they've never read those standards. So a better understanding of what you're buying is important, and how you specify it, I think, is important, and that would eliminate many of the problems we see within the industry.
Okay, that was my friend and colleague Bob Willis on episode number 1, recorded in my closet. So I'm glad to be, so to speak, out of the closet in that regard. Now we're going to hear from Rob Boguski. He is the founder and president of a testing company, contract testing company called Daytest. They're up in Silicon Valley in the northern part of my state, California. He has also been a guest a couple of times on this show. In September of 2019, he was on this show talking about the testing of circuit assemblies. Here's a quick message from my friend and colleague, Robert Boguski.
Mike, it's Rob Boguski from Daytest and your compadre on the SMTA board. Congratulations on your forthcoming 100th episode of the Reliability Matters podcast. I think I was one of your first 10 guests back in the summer of 2019. You invited me to come on the show and talk about some of the columns I've written and some of the sacred cows I've tried to explode over the years that have polluted the thinking in our industry or biased us one way or another. So thanks for having me on. I enjoyed it and have appeared one or two other times since then and enjoyed those episodes as well. As president of a test engineering company, I see reliability coming and going. Coming in the sense that testing reveals questionable workmanship coming off the line, and going because we see failed units months, often years after manufacture in our failure analysis business, and again, due to marginal manufacturing. Unfortunately for many, the green light on the test box means good, which means ship, which means money in the bank, which means cash flow, and that's very seductive and leads to short-term thinking in many incidences. It also contributes to long-term failures, but the short-term thinkers, of course, think it's someone else's problem, which makes it a bigger problem for everybody and contributes to reputational risk for our industry particularly and American industry generally. And ask the U.S. auto industry how that worked out for them back in the 70s, 80s, and 90s when everything left this country and the Japanese stole the mantle away from us for automotive engineering and quality. Yep, you bet reliability matters. Thanks for shining a light on the issue, giving it wider attention that it really deserves, and addressing things like short-term thinking, the same thing that begets substandard, suboptimal processes and shoddy products. Please keep talking about this. Please keep having impactful guests, asking the hard questions, demanding the right answers, and hopefully you can do it and do it in a wide variety of ways like you're so good at for your next 100 episodes. Many more years of success, and see you down the road. Thanks a lot.
Thank you, Rob. And I do remember the cars from the 70s. I worked on a lot of them, a bit of a motorhead myself. And yeah, those were not our best car days. A lot has changed thanks to what? Reliability, of course. My next clip from a prior episode is one of my, again, I don't like to use the word favorite because they're all favorite, but one that really stood out. and that was Patrick Stimpert. He is the director of manufacturing for a contract assembly company on the East Coast, in Pennsylvania, I believe, called Matrix Group. And what struck me about the conversation was how, in his opinion, U.S. contract manufacturers can compete with any contract manufacturer anywhere in the world. It's all a question of optimization. Even though labor is significantly lower as a cost standpoint overseas, it's not all about labor. And let's listen to what he said about that. So you're a U.S.-based, obviously, you're a U.S.-based, Western Pennsylvania contract manufacturer. With so many contract manufacturers offshore, Vietnam, China, Mexico, others, what are, besides logistics, besides you being down the street or, speaking the same language, all that, what are some of the advantages, in your opinion, that a U.S. manufacturer brings to the table? Maybe that advantage is not price, because labor costs are higher here. But what are besides price? Well, price isn't in it. But so besides being local, what are some of the advantages of working a U.S. company working with a U.S.-based contract manufacturer? What are the value adds, I guess, is the question.
So really the difference that everybody talks about labor, and quite honestly, in the contract manufacturer, if labor is your offset, then you have way too many manual processes and processes that are associated with any one customer or any one build. And so it really becomes down to how you can support rapid change. And then with that rapid change, the less human activity, the better it is. That you can pivot quicker. You can pivot quicker and take on new assemblies and all the rest of that. So if labor is the only discussion, and then you're doing something wrong as a contract manufacturer in the United States, because it should not be so much labor driven, because the automation is not that expensive. Especially if you've tried to hire people in the last couple of years, and if you think that automation is expensive, just keep changing the bottom 20% out in your organization. And I'll tell you how expensive that is, especially people that may not be as conscious about quality as you would like them to be. It only takes a couple big oops to really justify $150,000 to $200,000 co-young. It doesn't take a whole lot of oops to get there.
That makes a lot of sense. So in your opinion, because we can eliminate a lot of the labor, which is the advantage of offshore companies' labor, to your point, can a lean, well-run, well-oiled machine, contract manufacturer within the U.S., compete on a per-cost basis, a per-piece basis with pretty much any manufacturer in the world?
Yeah, so really tariffs would be the only things that could blow us up. But as far as automation and shipping cost and delays in ports and all the rest of that items, you should be able to compete, especially offshore. Maybe not so much nearshore, but having relationships with nearshores are probably pretty important as well, especially cable houses and stuff like that. But they're really, if you lean out your facility and you automate, especially like robotic soldering, where everybody was hand soldering, there's equipment now on the market that looks like it'll do about 90% of the through hole hand placing that was being done. There is inspection equipment coming on that will now do bottom side and top side solder and top side parts components. And so we don't believe we're on the cutting edge, but I got to tell you, it isn't much past the cutting edge of what we'll put in this place and run with. Because I do have that kind of one of that core principles is I don't want to put technology out on the floor that our people can't grow with and be part of. And so we do want it tested. We don't want it correct before I put it on the floor. But getting machine 2 of the build, we've done that here before.
We can compete with any country in the world. If labor is your major concern, you have too much labor. Interesting, very interesting point. Next, we're going to hear from my first, or not my first guest, but one of my earlier guests, which was Doug Pauls. Doug Pauls is a senior fellow at Collins Aerospace, and he was the chair of the IPC task force. He called it the Raiyo Group, and that was the committee that changed the cleanliness standard. We had a cleanliness standard for 40 years, and it was long overdue for a makeover. And Doug and his Raiyo team did that. And we're going to hear a few comments about what Doug thinks about reliability right now.
Hello, this is Doug Pauls, a technical fellow at Collins Aerospace in lovely Cedar Rapids, Iowa. I had the pleasure of being on one of Mike's early broadcasts, one of his podcasts, related to the work that I led defining the new cleanliness standards and IPC J Standard 001. I have to say it was a very enjoyable experience. Mike and I have known each other for years, and Mike is a natural at this sort of thing. I had a blast. You know, when you think about the general topic of reliability, there are dozens, if not hundreds, of aspects of reliability that you can dive into, but still not do more than really scratch the surface. I have spent over 35 years focusing on just two aspects of reliability: electronics cleaning and conformal coating. And I have to say, I'm still learning new stuff each day. There are precious few educational offerings out there in the electronics industry, especially related to the processes of manufacturing electronics. So when you find a knowledgeable authority, like Mike, who can relate things in a way that almost anyone can understand, well, that is a gem to be treasured. One of the things that we engineers do is to make things smaller, cheaper, faster, and lighter. And when you make things smaller, cheaper, and faster and lighter, that means things are getting much more dense in the circuitry. And when that happens, you have to constantly reassess what you know about various aspects of reliability to see if it's still relevant. Maybe you have crossed a threshold where what you knew before is now no longer good enough. You know, one of the benefits of being in the industry so long as Mike and I have is that you get to know the experts in various areas, and you can tap into that network of knowledge. I think that the Reliability Matters podcasts help people to plug into that network much faster. I think it's an excellent offering, and I recommend it to anyone who is looking to become more educated in electronics manufacturing. Mike, I want to thank you for doing this. I regularly listen to your webinars. You are a very, very smooth speaker. And often I like to see how you take a complex topic and make it more understandable to the lay individual. The changes in electronics manufacturing are happening so fast that it's easy for an individual to get lost. Your podcasts are a very handy navigational tool. Keep it up. I love what you're doing. Thanks.
Thank you, Doug. I appreciate those kind words. You've been somewhat of a mentor to me, not somewhat of a mentor. You've been a mentor to me. I've always respected your work, and we're definitely members of the Mutual Admiration Society. Our next, and you do sound like that. You sound like Doug. I know when I first started doing this, I didn't like the sound of my own voice. I don't know if I still do, but I've come to accept that's the sound of my own voice. I think it always comes as a shock to people when they hear themselves back. My next guest is kind of the partner in crime with Doug Pauls. He's also from Collins Aerospace, and that is Dave Hillman, who is in the process right now. I'm not sure if he's done with his epic journey, but he's in a kayaking, I don't know, something like 1,000 miles. Maybe Doug can chime in. He knows the details, but he's on a kind of an epic journey, an adventure. And we talked about one of the things that we've talked about most on this show, and that is voiding. Here's some commentary and some sage advice from Dave Hillman from Collins Aerospace. Dave Hillman, it's so nice to see you today.
Hi, Mike. Glad to be here. Looking forward to having a fun discussion today.
I was talking to a group of people the other day about voiding, because in 2020 there's nothing else to do, and I've asked several of my guests this question, and I've received answers back, and I'm going to ask you the same question. Is voiding overrated? And, IPC has the BGA voiding spec of, 30%, cumulative. I don't know if that number came from a tarot card or a fortune cookie or science or
came from Rockwell Collins data.
It did. Yeah, oh my gosh.
That. Absolutely. I know that history. My therapist said not to talk about it, but we'll talk about it anyway.
Well, I'm so glad I asked you that question, because the answer that generally I get back is, yeah, it's overrated. It's it's pie in the sky. It's rather random. So I am actually, which wouldn't surprise me, by the way, but I'm in the cleaning business, and we had a cleaning spec that was kind of chosen out of thin air, 35 years ago, right? You know which one I'm talking about, which is now gone, thankfully. But I was curious if the same phenomenon, resulted in a voiding standard, or if that actually was based on science. And if it was based on science, what criteria, this is kind of, I tend to ask questions that morph into several questions, all within one question.
We just got to remember to come back to the other side.
I know, right? There, right. Yeah, it's a trail of breadcrumbs, which will lead me to what types of technology or what types of environmental in-use applications, or what type of reliability expectations, et cetera, would determine if a certain percentage of voiding is too high or too low. So there we go. It's a compound question. We'll
start with parts and bounce around to the various regions. But yeah, and everything, we're going to end up talking about bottom terminated, but it really does have its roots in BGAs. One of my mentors told me that we as engineers should all have paid attention in sociology class, because engineering is easy, people are hard. And what has happened is that we've got this brand new technology called ball grid arrays. And when we got that, we said, well, we've got to see the solder joints. Well, what's the easiest way to see a solder joint? Well, we'll cross-section it. Well, okay, that's great, but I can't sell the product when you're done with it, Dave. So let's go to X-ray, because, X-ray in the medical world and X-ray in the dental world, and we've done X-rays. We kind of know how to deal with that. And so we X-rayed them, and lo and behold, what did we see? We saw voids. And the first thing, human reaction to something different is it's bad. No, it's different. So when we see voids, we don't know it's good. We don't know it's bad. We as an industry have to go determine that through data. And it was quite interesting when we introduced BGA criteria to the J Standard 001 National Standard. It was set at 10% was in the committee. We're talking about 10%. And Les Himes had looked at that and said, boy, that's awful low. And there were a number of people who Mike said, just like you said, hey, wait a second, voids don't really mean anything, especially a couple friends at Motorola. When Motorola was king with the cell phones, they had looked at it extensively, just hadn't published the data. And so Rockwell Collins and Lockheed Martin and Northrop Grumman and you name it, a ton of companies got together and looked at the available data and said 25%. And that's what went in. And then about 6 years ago, Rockwell Collins took a look at it, and especially, as you said, there were a number of people in the industry, hey, this is ridiculous. 25 is low. And so we did our test, and I'll remember that test quite well, because I took 40 circuit boards and I ran them down our process, and which ends up being about 250,000 BGA solder joints. And guess how many solder joints or voids in those solder joints greater than 25% did I produce? Right there. I counted them on both hands. That was it.
Both
10.
hands. That's it. 10.
We X-rayed every board, every part, and 10. And I'm thinking, okay, statistically, I have a problem. And I could deal with that. We did another set of boards, and we teamed up with a couple people. And it turns out if you want to make voids, the solder paste suppliers know how. And they will give you a paste that is horrible and will produce tons of voids. My bigger problem was going back to my boss and saying, hi, I have 40 test vehicles that I can't use. Can I buy another 40? I promised to use the first 40 for something else, which we did. But yeah, it is hard to produce voids in BGA solder joints. And we did the second round when we showed that you can have a void that's almost 50% of the diameter of the BGA solder ball sphere itself. And if it's going to fail, it's going to fail regardless of that void. There's been this long discussion, well, a void will blunt the crack growth, or no, the void causes the crack to grow faster. And in the end, it comes down to just good old global CT mismatch. If I can take a perfectly solid, no void BGA solder joint and fail it because it's in the wrong place, in the wrong design, in the wrong stress. So we went through the data again, Collins, Lockheed, HP, 10 or 15 companies got together, reviewed the data we had produced. We did a couple other tests, and in the end, 30% went in. And it's 30% of the X-ray image area. And if you go do algebra, which my co-op did and actually saved a very embarrassing math mistake in a published paper, that ends up being, if it's 30% of the X-ray image area, that's 57% of the diameter. And so, whether you're looking at it and thinking geometry or just thinking X-ray, very robust. And kind of like plated through hole fill, which probably something else we'll talk about today. If you're at that level, something's wrong. Something is seriously wrong. Our normal ball grid array voiding percentage today in our Coralville facility is 2 to 3%. We've teamed up with our solder paste manufacturer. We've refined the profiles, and the solder paste suppliers produce some great materials. You just got to use their materials. They understand what causes voids for most of it, and they know how to work that. So what happens when we get to QFNs? We X-ray them, and in that thermal pad, which you'll hear me call the belly pad, and the IO pads I call the fence, because to me, and you know this better than I do, trying to get cleaning solution past that fence to get in that other area is I think it's impossible. I don't know how you do it. It's amazing what the cleaning chemistry is designed and the equipment designed, how we even come close to doing that. The same thing, we looked at the belly pad. Oh, there's voids there. Oh, these are bad. And there's a twist to that. So when ball grid arrays, the voids, the only thing that void really related to was the solder joint integrity. QFNs came into being for two reasons. One, I want electrical functionality. I can push signal grounding through that belly pad. I can dump heat through that belly pad. It isn't just how good is the solder joint. There's functional needs. And that's where we got all wrapped up. That's why the industry has been, you don't hear the industry talk about BGA voids anymore. We don't. 30%, everyone hits it. But boy, the discussion in the committees about QFN or BTC voiding, that's been the latest craze.
Thank you, Dave. We heard from Doug Pauls. Dave was on a kayak going from the sea to at the start of the Missouri River and down to the Gulf of Mexico. And he's presently in southern South Dakota. And Mark Hughes commented, I love this guy. Go Dave. Yeah, I totally agree with that. My next next clip, was from a very fascinating speaker, very engaging speaker. And he's a reliability expert, and that's Doc Brown. And he cited something taken right out of the newspapers. Should I say newspapers? Right out of the news broadcast or feed that you get. And that is a reliability event, which was in the news, and how it totally could have been avoided and how the problem was missed. Here's Doc Brown.
Let's say you're working around your house and you're going to build or rebuild a deck. One of the first things you're going to do is go to your city or county office and get all the standards that are required, the building codes that you're going to be working with, and it's going to tell you things like nailing schedules and joists and spans and all that kind of stuff, and you're going to build it to that standard. So this was an unfortunate situation that occurred a few years back at Senior Skip Day, where a bunch of seniors took the day off, and they're all happily celebrating. You can see some of the high school seniors there lifting their adult beverage that they probably shouldn't have been consuming, and they were dancing and having a good time. So there was a failure. You can see the deck kind of beginning its collapse there before, and then the after picture shows what happened. Mercifully there were no fatalities, or I wouldn't be showing this. But so what happened here? It was built to standard, and yet it failed. So the underlying supposition behind those building code standards are that the loads on the deck are going to be static loads. That is, they're just going to be dead weights of people on the deck or other things on the deck. They do not take into account dynamic loads, that is, people moving and dancing, nor do they take into account what's called as reasonably foreseeable misuse. So this is a legal term that we as design engineers are required to operate to, that we need to have our designs tailored not only towards the intended use, but also legally foreseeable misuse. So in the simulation world that we work at in ANSYS, we have a lot of really excellent simulation tools that are available. So I like to kind of tee this up in terms of a catchy little phrase that I'll offer for your consideration, and that is rules versus tools. So design rules are great, they're necessary, but they're not always sufficient. And that's where simulation comes into play.
And that's where simulation comes into play. Don't they wish they had done some simulated testing? We're going to hear a couple of comments from my friend and colleague Bob Willis, who, as you may recall, was guest number 1 on episode number 1. He was kind enough to send a few comments about his thoughts on reliability on the show. So here's Bob.
Hello, my name's Bob Willis, and I'm from bobwillis.co.uk. I was a very early guest on Reliability Matters podcast, and it's been a pleasure to provide some insight into the different types of failures that occur in modern electronic assembly. It doesn't matter if we're listening to a podcast 10 years ago, 5 years ago, or 5 years in the future. Some of the process issues that we face will continue. And although we understand why they occur, there may be different issues that have caused that problem to reoccur in a product. Sometimes what happens is we find a solution to a problem, however, we don't find the root cause of the problem. The key thing with any failure analysis is finding root cause, but sometimes companies are just too eager to just find a sticking plaster to allow them to continue production and meeting customer requirements. You always need to go back and find the root cause of the problem. Otherwise, the problem will reoccur, possibly slightly different, but it will reoccur. I think that the recordings, the Reliability Matters podcast, are a useful resource for engineers now and in the future, but it also gives an insight to how different engineers deal with problems. And of course, sometimes people use Taguchi experiments, sometimes people use a scientific approach, sometimes people just jump into a problem and because of their experience are able to solve that problem. So regardless of what and how a problem is overcome, it needs to be documented with photographs, x-rays, reports, etc. And that's how we pass on knowledge. But with Reliability Matters podcast, it's a discussion between engineer to engineer, and I think that's extremely valuable.
Thank you, Bob. Okay, now we're going to go to the Meet the Press episode, which featured Phil Zarrow, Jenny Huang, Bob Willis, and Ray Prasad. Here we go. Certainly class 1 device. No one's going to die if I don't get the warning. But then again, I'm going to put it in my pocket. I'm going to go outside in the snow and the rain and the heat and the humidity, and maybe I'll take it diving, and it will fail because it's not a Class 3 device. It's a Class 1 device. It's designed not to live forever. So that's kind of the greater point is if we're going to connect everything, even things that aren't life-saving, that don't necessarily need high reliability, it's still not a good idea for this connected pen to fail 6 weeks, after I buy it for $35. So that's kind of the point I'm making is
but Mike, some of it is kind of silly, like this pen for the ink. I mean, the way we have the pen is cost few cents and whatever. I mean, some of it is gimmicks just to make a pen that should have been less than $1 in the first place, and you just throw it. I mean, why do you need to connect all this stuff? So there are some.
That's exactly the point I'm making. Is why do we need a toothbrush that is connected to the internet? And there are today toothbrushes that can connect to the internet, so you can spy on little Johnny or Janie to see if they brush their teeth. That's kind of the point. Is we're connecting things that are silly.
Yeah, some of it's silly.
Some of it is great. Most of it is probably great, but there's a certain amount of stuff that's just gimmicky.
I think I agree with both Ray and Jenny. And on the one hand, as Jenny said, there's a lot of fantastic application enabling that we have. Perfect example. Here we are. Thanks to the Internet of Things. On the other hand, I don't need to tell Alexa to turn on my electric toothbrush. And, so it's, Ray saying it's technology for technology's sake. Like, why? And so in between those two extremes kind of lies, what's practical and everything else. But the other issue with the Internet of Things, I think, is it's more sociopolitical, but the loss of privacy. And I think it's also a generational thing. From our standpoint, I think we look at things being hacked, the disruptions we have, and the potential for disruption to technologies, and certainly, with our end of the industry. On the other hand, I have discussions with my 30-year-old stepdaughter, and the proverbial millennial. They no qualms about loss of privacy or anything else. Alexa everywhere, social media everywhere. So it may be a generational perspective here as well, but
probably.
But I agree. There's a lot of really great enabling stuff. It's fantastic, but it's also a lot of technology for technology's sake.
Sure.
I think the most important thing is, as has already been said, is that there is a limit, but there's not a limit in the imagination. So where the imagination can come up with ideas, then we can go in that direction.
Sure.
But all I would say is that I wish I'd actually registered the IoT, Internet of Things, and 4.0 to all the conference organizers, marketing companies, then I would have made a fortune without any technology whatsoever.
Sure.
I think that to me, connecting things together and taking valuable information and sharing it with another machine, another system, to me as an engineer, seems obvious. Now, I know there are limitations, but that's up to the engineer to overcome those problems with getting the 4 or 5 companies in a room and talking to them. But unless we take advantage of that information, because there are so many AOI systems, SPI systems, the data's there, but nobody knows what to do with it. There's just too much of it. So again, engineers, and we must make sure the younger engineers go somewhere that perhaps some of their peers don't go on a regular basis. It's called the shop floor. And look at real things, not just the data, look at real things, because that's where you learn how problems actually can occur. And talk to the people who run the machines, because they're 24/7. Perhaps they don't understand about certain things, but they see a lot of stuff.
Yeah, I remember years ago, I learned the concept of what we called MBWA, management by walking around. And it is amazing. As you said, Bob, talk to the people, because people have stories. They're desperate to share it with someone.
That's one of the key thing in the audit that I do. And, in the conference room, everybody just says the right thing because this is what they do. They're quality manager. He's used to talking to everybody. Oh, we do this. Yeah. And then I said, okay, so one of the requirements I have is that we talked earlier that I missed that can be done remotely. I tell people, okay, just leave me alone for a day, and I'm not going to interfere with production, but I do want to be able to talk to the people on the floor, to go talk around. It's amazing, the people who are following these things. Sometimes they have no idea what the guy in the conference room told me. And so, and they are the ones sort of making the decision on the shop floor. So exactly, Bob is right. You just go on the floor. That's where you'll find out the real thing, because those are the guys making the decisions,
Yeah. The best experience I can ever say is working in a plant in Texas. And I as Ray said, I was just left to wander around, look at anything I wanted to, ask anything I wanted to. And just directly after the audit, one of the important things that one of the supervisors said, "Can we have a recording of your voice?" And I said, "Why?" He said, "Because you've got this strange accent. All the girls on the shop floor love it."
Oh my goodness!
I had to do
Bob.
Anyway, slightly offline.
But, charmer.
It's the English accent, I guess.
Now, if you call in the next 20 minutes, we'll cut Bob's voice to only 20 pounds for 6 words. Oh my goodness, that's funny. They just wanted to hear your voice, the soothing, calming voice of Bob Willis.
You charmer.
Well, see, now you're finding out industry secrets here.
Yeah.
So,
Mike, about the big umbrella of IoT, perhaps what apply to our industry will be under the subset of IIoT, which is industrial IoT, which is perhaps we are most more interested in. If we look at the industrial IoT, and then you mentioned about which we didn't respond yet, is about the class 1, 2, 3 under the J standard, or under the IPC 610 or J standard 01. If you don't look at the industrial IoT, if I have to make recommendation, and I would say I would not classify as a class 1. Mostly would be class 2 or some class, maybe class 3. Because once you're really looking into the IoT, implement into the system, and has quite a trickle-down effects, particularly when we linked into the 5G network, because that's really another big piece of the industrial IoT is really needed to function hand in hand with 5G. Then once you're doing the wireless, the system become much more complex. Mm-hmm. So that hardware module, we look at our industry to produce the IoT modules, which is, for example, with the RF, the power units, application processors, the base station processor, all those components on this assembling. And then our reliability level has to be reached to a certain level. So I think based on the current existing for standard industry standards, if I will have to make recommendations, if people ask me, I would say it will be class 2 or class 3.
Mm-hmm. Interesting conversation. I have a couple of comments. For some reason, they're not coming up on my control system here. But Mark Hughes said, if I had a nickel for every time someone asked me for a recording of my voice, I'd still be penniless. And Prasad said, are the server systems being built to class 2? I don't know the answer to that. I would assume servers are probably class 2, but it depends on the nature of the server. I'm sure the military servers are probably class 3, but most commercial servers, I would assume, are being built to IPC class 2. The next person we're going to hear from is my friend and colleague, Eric Camden. Eric is a failure analysis investigator for Foresight Laboratories in Kokomo, Indiana. I like to liken his job to a CSI, a crime scene investigator, only in this case, the crime usually has something to do with process, which usually has something to do with a lack of reliability. Here's a few words from Eric.
Hi, everybody. This is Eric Camden, lead investigator at Foresight Labs in Kokomo, Indiana. I was one of Mike's earliest guests on the Reliability Matters podcast, and what I remember from that time was Mike and I having a relaxed chat about different issues affecting the electronics industry with regards to long-term reliability in different field service environments. I think we spent the bulk of that time discussing the impact that QFNs have had specifically on reliability, but in a broader sense, we were discussing the continuing efforts of miniaturization and how that drives the need to better understand ionic residue sources, as well as the best way to analyze the residues in order to determine that product's risk of failure. I was only covering one small part of the full puzzle that is reliability, but with the podcast, Mike talks to people from every corner of the industry, from raw component manufacturing, PC fab, all types of assembly and testing, all the way up to final packaging to the end user. The podcast is a great resource if you're looking for specific information about a part of the industry that is giving you trouble, or even better, a place to turn before you find that field failure. There's a lot of really good information freely available in our industry, and the Reliability Matters podcast is certainly among the best sources to find it. Thanks, Mike, for providing this valuable service, and here's to 100 more episodes.
Thank you, my friend. I appreciate the words, Eric. Eric was a guest a couple of times on the show, and he always has some fascinating visual assets to show of things that have gone wrong. My next clip is from Professor and Dr. Eric Fossum. You remember the old American Express commercials? You may not know me, but you know what I invented. That's Eric. Eric is the only guest I had on the show who's won an Emmy. Now, what is someone in this industry doing with an Emmy? That'll make sense when you hear what he invented. He is the inventor of the CMOS image sensor, better known as the digital camera. Yeah, that was him. And whoever said that engineers and scientists and PhDs don't have a sense of humor hasn't met Dr. Eric Fossum. So does the fact that your invention changed the world, including people and companies and entire industries, does that still startle you? Do you wake up once in a while and go, that was me?
Yeah, actually it does. I mean, you would think I would be used to it, but now it's become so embedded and so ubiquitous. Most of the time, I don't think about it. But every now and then, there's someone using a camera or something like that, especially if I don't know them, they don't know me. It's like, wow, this is like really weird to like see people using your technology every day, stand next to them. It's like that old American Express commercial. You may not know my name, but you know my technology. And,
right. See, you're a bit more humble than me. I think if I had stumbled across, I say stumble as if you won the lottery, but if I had invented something like that, I would probably be inclined to just tap people on the shoulder and go, hey, that's me. So, well, you're not more like me.
I'm embarrassed to say, but occasionally I'm a goofball and I do that. I remember some couple taking a photograph in Europe and I said, excuse me for a second, can I just photobomb your picture? And they kind of looked at me and I had my wife take the picture. And then after it was over, well, they were very polite, but they were like, had no clue what I was doing there. They looked around and I explained to them what it was. They still didn't quite believe me, but then about 2 weeks later, I got a email from them, like, holy cow, I can't believe it. We met.
Dr. and Professor Eric Fossum, inventor of the digital camera. We also talked quite a bit about unintended consequences of his invention, where his invention arguably has connected the world and allowed us to share pictures of our grandkids and vacations and things like that. He did express some concern over some of the more nefarious uses of camera systems like facial identification systems that governments are using and things like that. So definitely some things to ponder. Thanks, Jason Keeping, for your kind words. I appreciate you being on this episode, and thanks for your kind words of support. Next, we're going to hear a few words from Mark Hughes. Mark Hughes is the research director at Royal Circuit Solutions and Advanced Assembly. He does a lot of podcast and YouTube stuff, and he has a very unique and entertaining form of getting complex information out to users. Here is a few words from Mark.
Mike Konrad, Mark Hughes here, Research Director of Royal Circuit Solutions and Advanced Assembly. I just wanted to thank you again for letting me be part of your journey to 100 episodes of Reliability Matters. I had an absolute blast being on the show and got to make a new friend, which is something that's pretty hard to do during this pandemic. If you ever want me back, all you have to do is ask, and pay $100. No, I'm kidding. I'll come back anytime for you, buddy. Anytime at all. I really think this podcast helps listeners learn the importance of reliability and helps them to learn some lessons from others on what to do and what not to do. I've been told that an engineer's knowledge goes out of date within about 4 years of them leaving school. So unless you're constantly learning and constantly educating yourself, you're going to become pretty useless over the course of your career. Listening to Reliability Matters is just one of the ways that you can stay relevant in this field. And I hope and encourage anybody out there to spend a few minutes on your drive to work with Mike Konrad buzzing in your ear. Reliability is exceedingly important with modern circuit boards. As things keep getting smaller and more precise, the things that we got away with before are things that we can no longer get away with. As we start this journey to Ultra HDI, component features below 50 microns. In the manufacturing process, we've got to start worrying about every little bit of dust and debris that's floating around the room. If something the size of a dust particle lands on your board and you're dealing with 3 mil traces, no problem. But if you're dealing with, 1 mil trace and below, you got a problem. And that's something that might be a failure now. It might be a failure in the future. But if we don't keep our boards clean and our environments clean, you're going to end up selling somebody something that doesn't work, and then they don't come back to you. Nobody wants that. Anyways, Mike, you're a great guy. I really appreciate what you're doing, and I encourage you to keep it up. It's a great service you're providing to the community. Hope this helps. If you need anything, you can always reach out and ask. Thanks so much, Mike. Bye.
Thanks for those kind words, Mark. And it didn't even cost me $100. I got that one for free, so I appreciate it. For some reason, my comments aren't showing up. I can't put them on the screen, but Mark did state, if I ever invent something amazing and get filthy rich, you'll never hear from me again. Everyone will just ask, where'd Mark go? Where's Mark? And no, Mark, you were not long-winded. That was just perfect. Our next clip is from an episode called Meet the Press, and we brought in some journalists from our trade industry, and to talk about all sorts of things. And I think the topic of discussion at that one, and still is, component shortages. And this is Mike Butow, from Circuits Assembly, Phil Stoughton from Scoop TV, Trevor Galbraith from Global SMT and Production, and Eric Miskell of the EMS Now show and online publication. And again, we're going to talk about component shortages. I'll see you in a few seconds.
It doesn't seem to me that the component OEMs are rushing to bring more capacity online. So whereas, and I tend to agree with Trevor that the lead time started going out pre-COVID, but the things like MLCCs and some of the crystal stuff, that's always kind of hard to come by. That's always a difficult thing. But it's more just everyday resistors and chip caps and things like that. When those times start going out, then you say, okay, yeah, there's something going on here. My take is that the effects, right? You've got this 3-year. If we go to the end of 2022, it would be the longest bull run for component shortages that we've ever had, even more than the 99, 2000, 2001 run. So, people are just putting a stake in the ground and saying end of 22, maybe, I don't know. They're kind of guessing, right? And we're all just sort of guessing there. So that's why I try to focus more on what are the actual impacts, right? So what I'm seeing is that used equipment sellers are now getting into component sourcing. And that's a weird thing, right? Because we're used to them going in and buying up factories that are going out of business, and they buy, the Metro racks and the ESD lines, and they get all the shelving and all that. And there's always parts on those, right? And what they do is they just throw all those in a dumpster. Now they're saying, shoot, I can make money off these parts. So they're getting into component reselling, and they're taking that stock room and they're basically putting it up all on Octopart. You know, you go to Google Maps and you look at the building, you're like, that doesn't look like a factory to me. That looks kind of more like a trailer, you know, but you can buy parts there. So the counterfeit and what's happening is EMS guys are saying, hey, look, you know what? I got this part. I've bought racks from these guys before. I think I know where this came from. Let's build a few boards, and if it's reliable, let's run with it. And the OEMs are saying, okay. And so you're going to end up with no traceability. Lots of counterfeit parts, moving into mainstream products. I mean, that's really where the mess is going to be, right? So all this talk about wanting to know the origins of the part and being able to see everybody who's touched it and all the rest of it, that's out the window and will be for some time to come.
Yeah, I think adversity and opportunity are the same sides, are different sides of the same coin, and that applies to nefarious operations as well. The pandemic has given companies in our industry a unique advantage or opportunity. In the early days of the pandemic, when everyone switched over to making ventilators and things like that, that was clearly an opportunity. The fact that our industry was deemed essential very, very, very early on, like the next day after state shut down, was an opportunity. But then again, opportunity is very widespread, and clearly I worked a lot with on a production side with the counterfeit conference, the SMTA counterfeit conference. And that business is alive and well right now. And the component shortage only highlights that.
So can I add one thing? And then I'm dying to hear what Eric has to say about this, because his background, I think, is just goes right into this, right? So, I mean, at least one very large distributor is at the point where they're saying, these are the parts available. What can you make with them? Right? It's like MacGyver. And so, that's going to lead to respins and whatnot. And so the trickle down, right, is that, the question becomes, will EMS companies start to push the OEMs to share the cost of parts, almost like a consignment model? And, because otherwise that's a lot of carrying costs for EMS guys, no matter how big or small they are. And even for OEMs like you, Mike, right? So you're tying up a lot of capital in parts. Now, you get to make the decision whether you're going to redesign the board or not. But the EMS guy doesn't have that option, right? It's the OEM may say, hey, look, you can't get this part, let's redesign. Now the EMS guy is stuck with a lot of material that may or may not be reusable inside their own factory. So who's responsible for that inventory when a board is inevitably respun?
My friend and colleague, Fred Schenkelberg, he is the creator of Ascendo Reliability. You can find that site at reliability.fm. As I said earlier, they syndicate the show. And if you go to reliability.fm, you'll not only see this broadcast, you will see dozens of reliability-based podcasts and webinars and things like that. He has dedicated his work to creating this free resource for not just our industry, but other industries as well. Here's a few seconds of words from Fred.
Hi, Mike, and congratulations on making 100 episodes for the Reliability Matters podcast. That's a remarkable achievement for any podcast, and I'm quite sure you're just getting started. The content and the information you provide is stellar. It provides great practical advice, insights, and nuanced, but also very much practical and basic. So you reach a wide audience, you talk to amazing people from across the industry, and it makes a difference. The more people can understand and create reliable circuit assemblies, which go in just about everything from satellites to cell towers to switching stations to our vehicles, even my coffee pot. We count on them on those elements of our life to just work. And that's what reliability is about. And so the show that you're putting on makes a difference. I enjoy listening to it. And here at Ascendo Reliability, we have the reliability.fm podcast, Reliability Podcast Network, and we're very proud to have you as a member of it. So keep going, Mike. I'm looking forward to the next milestone, which, by the way, is not 200, but 1,000. And I'm quite sure you'll have a great time getting there. Talk to you soon. Bye.
When I started this, thank you, Fred. When I started this podcast, I thought we would do about 10 episodes and then move on to something else. I didn't have any any vision at all that we make it to 100. And now Fred just said 1,000. So I don't know if we'll make it to 1,000, but we'll certainly keep going until no one shows up. I want to mention a comment from Rob Boguski. The pandemic has given a lot of shady operators a convenient cover to gloss and explain away over many shortcomings and questionable practices. In a way, it has become the universal excuse du jour. That's absolutely true. I'm not even going to comment more on it because I'll just get all agitated. That's very true. Pet peeve of mine. The next clip, very quickly, is an audio-only clip from an earlier show. And that was episode number 15. And this features Michelle Ogahara from Seika and Sherry Stepp from Kaizen. And they talked about their experience as being women in the electronics industry. Here we go. What I'd like to ask the both of you, or what are your experiences as a female in this industry, both in the past and in the present? And feel free to share other experiences from other women that you talk to. I don't expect you to, say anything bad against your employer. I don't want to put you in any kind of predicament. But just as in general, what are your experiences as a female in this industry when you first got into this industry, both of you 20 plus years ago, and all the way through to today?
I think that for myself in the beginning, it was really natural to feel a lack of confidence simply because I was new in the industry. However, I do feel that women in general are doers, multitaskers, and we handle all aspects in our daily lives. So nonetheless, I think we take this for granted and don't really think that this is a special capability. We just feel like, oh, this is a normal thing. And what we should realize is that this is a real skill set, and we can often allow ourselves to get up to speed and excel in everything or anything that we have a determination or a mindset to accomplish. But, it's no need to take a back seat and just, drive it forward, be the driver. I find now that I'm older and with more experience, I use my voice quite a bit more and show more conviction in my decisions and recommendations. But I know that it took a lot longer than it should have for me to reach this level, comfortably. So I would just really, recommend to women out there that understand that we do have this capability that and we should take charge and feel free with confidence to understand that this is something that we can bring to our job and be an asset no matter what position we're in.
Very good. Sherry, are there differences in a female experience in this industry 27 years ago versus
absolutely.
Today?
When I started, I was one of the very few women in the sales and marketing arena, or just in the business entirely. Kaizen's always been really good about hiring women. We have a lot of smart women that work here. As a matter of fact, International Women's Day was last month, and I counted how many we have, and we have over 30 women that work for Kaizen globally, and in a variety of positions, from accounting to chemist to applications technicians, salespeople, a lot of women in management, including myself. So we've been given a lot of opportunity here based on merit rather than our gender. But that's not necessarily the case. I would go to conferences or trade shows, and you look around and you don't see many people that look like you. And you would think that we would just band together and gravitate toward each other. But it's also a very competitive industry, I think. And sometimes as we're trying to make our place, we forget that there's other women that need to be pulled along. So, but today, you go to those same trade shows, you go to those same conferences, and there are women who are presidents of their companies, they're engineers, they're giving those technical conferences, they're giving presentations, they're leaders, and it's really nice to see a bigger balance. We still have a little ways to go. I believe that there are some areas that we need to increase in number, I think, with qualified younger people, because our industry is aging. So bringing in new people, and not just new young men, but new young women who are chemists and engineers and have MBAs and just have that drive to be able, even, machine operators, all of it.
Thank you, Michelle and Sherry, for those comments. Real quick, we're going to hear from Chris Denny. Chris Denny is the CTO of Worthington Assembly, a contract manufacturing company. This came from episode number 70. He was a guest on actually episode number 74 back in August of 2021, last year. Chris is also the host of the Pick Place podcast. There's not too many podcasts for our industry. His is one of them. And he and Melissa are both co-hosts for this endeavor. And I would highly recommend his and her podcast. It's very informative. You can find it on Apple Podcasts and pretty much wherever you get your podcasts. Just search Pick Place Podcast. Here's a couple of words from Chris.
Hey, Mike. This is Chris Denny from the Pick Place Podcast, and sometimes known as Chris Denny from Worthington Assembly, the CTO for Worthington Assembly. Well, my experience being a guest on the podcast was excellent. I really enjoyed myself. I had a great time. It was fun to chat with you, Mike. I think you're a great host, and I think you ask great questions, and I think you do a great job educating your listeners and being able to get out of your guests information that is valuable to the listeners. I think it's so important that these types of educational programs exist within industries in general, but specifically our industry. Personally, I think there's too many silos of information out there. I think there's too many gatekeepers of knowledge, and there needs to be more sharing. There needs to be more forums for people to be able to share this information. And I think a podcast is a great way of doing that. I really appreciate people who produce educational information. I was, and probably still am, a bit of a novice engineer at one time. And the little bit of information that I could find on the internet was so valuable for me back then. And being able to interact with other engineers in person is mostly how I picked it up. But now we have material like this where we can take in information while we're driving our car, walking our dog, whatever it takes, washing the dishes, and learning at the same time about how to become better engineers, how to become better manufacturers, how to become better designers of products, and create something that is going to last a long, long time, and ideally could even outlast us. I think reliability in modern circuit assemblies is so important. Whether it's a ventilator that is literally keeping somebody alive, and we all know how important that is to make sure that those circuit boards are reliable, or if it's simply a matter of a microphone so that some podcaster can record his thoughts into it reliably without frustration and without piling up a landfill of old assemblies that no longer work. When you make something that lasts a long time, it's a great experience because you have something that can continue to be used for decade after decade and produce something that people appreciate. I just think it's so important that we continue to push this industry forward and setting the expectation that a reliable product is the only product. I'm so grateful that this podcast exists. As I said earlier, I think more of them need to exist. I think more YouTube channels need to exist. I think more meetings need to exist where people can share information and publish information and learn from each other. And I'm so grateful that you started this podcast 100 episodes ago so that we could all learn from it. Thanks so much for doing that. Keep up the great work, and I will continue to hear you for years to come. Thanks, Mike.
Thank you, Chris. I'm not really sure how many people are listening to this podcast while they're doing dishes, but I get the point. But I appreciate those kind words, and good luck also on your podcast. I know it's doing quite well. We're going to start wrapping this up. I appreciate you guys being here. You've been here for longer than I expected, but that's just the way these go. Another reason why I don't do these things live. our last clip is with Amit Dror, who is one of the founders of Nano Dimensions. And the clip doesn't really talk about technology. That episode does, but the clip doesn't. However, sometimes we end up getting some just golden nuggets of advice that you can apply way beyond our industry. And I'll let Amit give us that advice. There is one question that has absolutely nothing to do with Nano Dimension. But in looking at your bio, you're kind of a serial entrepreneur. This is not your first rodeo. And one of the companies that you founded just stood out, and I have to ask you about that. Milk and Honey Distillery. What's that about?
Well, okay. So the credit goes to another co-founder of Nano Dimension, Simon Fried, friend of mine. And he actually came up with an idea just before we founded Nano Dimension. He said, we live in Israel and there is not even one proper whiskey distillery. And I said, well, Simon, there isn't proper whiskey distilleries pretty much anywhere aside of, Scotland, Ireland, the US.
There you go.
You don't get them.
Sure.
And he said, it's about time to have one in Israel. And we hooked up with another co-founder of the Milk and Honey Distillery. And we just decided we're going to have something we could all be proud of, which is a proper, real whiskey distillery. And we did. We just said we're going to do it. Today, it produces more than 250,000 bottles. It actually wins a lot of prizes. Just won quite a few awards in recent few months. And we are exporting it to, I guess, 24 countries. That's obviously, amazing. US is a major market, so you should give it a try.
I will look for it.
My subjective opinion that it's pretty good, but hey.
I will definitely look for it. You don't pick easy projects, do you? You don't pick projects with immediate returns. You can't just open a distillery and sell a bottle of whiskey in a day. There's things like aging and things like that, right? So
I think the key thing in life is do things you're passionate about rather than shortcuts, because we all need to bring on a salary to live, but if we're not happy with what we're doing, it's pretty difficult. So as long as you're passionate about it, you do it. And I'm pretty passionate about whiskey and also about transformative technologies.
Yeah, well, that
I see how it's linked.
So clearly, a bottle of Milk and Honey whiskey is included with every Dragonfly system, right?
Well, now that you mention it, I guess it is.
Now it is. You heard it here first. The key thing in life is to do things you're passionate about. It's pretty sage advice for a technical show, especially. A sincere thank you to my 117 guests that I've had the privilege of learning from over the past couple of years. And of course, the 20,800 plus people who have downloaded this content from the show. Without all of you, listeners and viewers, I would just be a talking head, and Lord knows we have way too many talking heads these days. Again, a special shout out to Mike Buteau at Circuit Assembly Magazine's PCB Chat for syndicating the show, as well as Fred Schenkelberg at Sendo Reliability at reliability.fm. PCB Chat can be found at pcbchat.com, and Sendo Reliability again at reliability.fm. Thanks for being part of the Reliability Matters podcast family. I really appreciate you being here, and thanks for being part of this grand experiment that we're doing. We'll keep it going as long as all of you keep watching and listening. Thank you. Be safe, be healthy, be happy, and most importantly, keep doing it right.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.